that you will calculate first of all the functional value at minus 3. So f minus 3 will be what? 5 into minus 3, that is minus 15, and minus 3 that is minus 18. And then you will calculate? You will calculate limit x tending to 3 minus 3 plus. So minus 3 plus what it would be? The function is like this. It is 5x minus 3. So what you will write? You know that this is a polynomial. This is a polynomial, and in polynomial you know that the limiting value is equal to its functional value. Therefore, you can just substitute it, and what you will get is 5 minus 3 minus 3. So it is again minus 18, and then limit x tending to 3 minus 5x minus 3. So it would be again what? 5 minus, see, 3 minus, as a matter of fact, see what you should put it here. In 3 plus, see, you can put 3 minus 3, okay, 5x minus 3 it is, you put here better minus 3 plus h, okay, and then close the bracket. And then see what you can write is h tending to 0, and then you can put it like this also. This is another way of doing the same thing. It is 5x, because now see this function will depend upon h. So what you will do, wherever h is coming, so then you will put 0 here, and you can put 0 here because you know that in a polynomial is a continuous function, and then you are justified in putting x tending to 0 straight away the value of the function, because if it is a continuous function, a polynomial is a continuous function, therefore therein the limiting value will be equal to the functional value, and therefore you are justified in putting h is equal to 0 here. So this will, and at place of x again what you will put? So fx minus this, and you have to find it, no, h is not tending to 0, h is tending to 0, find it is, but here again then what you will put x here, x again here you will put 3 plus h, okay, and then see this will become minus 15 plus 0, and then minus plus 3, so this is 18, and likewise you can do here 3 minus, see one way, there are two ways now I tell you. Better, see, you write it is a polynomial in x, so what you can do, and in a polynomial is a continuous function. Since it is a continuous function, therefore you can put the limiting value, therefore limiting value will be equal to the functional value. So better you put f minus 3 and show that it is equal to how much? It is minus 18, please see, 5, it is minus 3 here, minus 15, and then it will be how much? It will be minus 3, so minus 18. I will just come back to this thing. 5 minus, so minus 18. Let me do this thing again here, because it became a bit confusing. Here also, see, you can well write what? Limit, one way, I will do it in the both ways. So one way would be that you are writing 3 plus 5x minus 3, and you simply write it is nothing but 5, and at place of x what you can write? You can write minus 3 plus h. It is minus 3, please remember. Minus 3, and what else? Minus h, and then minus 3. So what it will be? Minus 15, and then plus 5 minus 5h minus 3, and then this is minus 18 minus 5 into 0, because h will tends towards 0, or see, sorry, what you do, don't even make use of the h also. You simply write it is a continuous function and put x equal to minus 3 minus 3. Because this is a polynomial in x and a polynomial is a continuous function, and when it is a continuous function, therefore the functional value will be equal to its limiting value. So in order to find the limit, what you will do, you will simply put the at place of x minus 3 minus 3. So this will be minus 18. So see this, what you are finding, that functional value is minus 18, left hand limit is minus 18, right hand limit is minus 18, therefore all left hand limit is equal to right hand limit, that is therefore what you are showing is that the limiting value is equal and is equal to minus 18, and this is also equal to the functional value, therefore your question is proved that the function is continuous. Similarly, you can prove for 0, you can show it for 5. Now see one more thing, there is one more way out for proving these types of results. See, I will show you how. See, one other way that you please try to understand, it is limit. If you don't want to write fx is equal to find out, and you have to find it, suppose its value at minus 3 plus, you have to find it out. So what you do, you write here, you substitute, put x is equal to minus 3 plus h, and see when x tends to minus 3, this implies s tends to 0. This implies s tends to 0. So one way would be that here wherever x is coming, that you can replace with minus 3 plus h minus 3, and you can write like this thing. And x tends to minus 3 plus, so better you can write limit h tends to 0, and what else, minus 15, and what is this, 5h and minus 3. So this is limit minus 18 plus 5h. Now see this thing, you can write limit s tends to 0, and then see limit, here this again is a polynomial in h. So what you can write is minus 18. Now don't write it, because limiting value of a polynomial is a continuous function. A polynomial is a continuous function. Please see, this reasoning is very important. What you will write, this is a polynomial in what? H. See, both ways you can do it. Either you can do it in the earlier way, or you can also do it like this way. Now there will be a polynomial in h. And then you say, since the polynomial is a continuous function, therefore this will be, therefore its limiting value will be equal to its functional value. So what is this functional value at 0? This much, that is minus 18. And hence this is another way of doing the things. Either you write plus or you write minus. So both ways you will get the same answer. So this is question number 1, you can do it. Basically you are making use of only this definition. Now question 2 you look in. Question 2 is examine the continuity of, this is second question. Very easy question, and I have already told you that only verbal questions they are. Question 2, what it says, examine the continuity of the function fx is equal to 2x square minus 1 at x is equal to 3. You have to find whether this function is continuous at x is equal to 3 or not. See, this function will be continuous everywhere in the domain for the simple reason that it is a polynomial, and you have already proved that a polynomial is a continuous function. You can quote it. Since polynomial is a continuous function, therefore limit x tending to 3 fx will be equal to limit x tending to 3 2x square minus 1. So this will be equal to what? 2 into 3 square minus 1. That is 9 to 18, 18 minus 1, 17. And here please write down, polynomial is a continuous function. Is a continuous function. This reason you are making use of here. Because polynomial is 2x square minus 1. It is a continuous, and in a continuous function, limiting value is equal to what? Functional value. So functional value at 3 is what? See, simply where x is coming, replace it by 3. So 17. This is how. So this is what you need to do. Here, continuity of the function you have to verify at x is equal to 3. So that we have done it. And so this is the limiting value. And what is the functional value at 3? Again it will come out to be 3 square minus 1. 3, 3, 9 to 18 minus 1, 17. Since functional value is equal to limiting value, therefore function is continuous. Therefore function is continuous. Then again see, in the third question also, you have to examine the following functions for continuity. So again see, hardly anything. In the third part also, you have to do nothing else, same thing. Here, what the theorem which you would be using is fx is equal to any one part. Suppose C part I am doing, third C part I am taking. Fx is equal to x square minus 25 upon x plus 5, suppose it is given. Now see, here it is obvious that functions, the domain of the function, whether it is given or not, but here x is not equal to minus 5. Because if x plus 5 is 0, the function will not be defined. So x is not equal to minus 5. For rest of the things, this thing, function can well be written to be what? X minus 5, x plus 5 upon x plus 5, and then this cancels, so this is x minus 5, that's all. So this is your function. This is what? A polynomial. And as such, it will be continuous everywhere. So it is a continuous function, you can write it. So third question, done. Now, for question number 4, please look in. Question number 4. Simply, for proving this thing, for checking the continuity, see, you need not to do anything. You simply write fx is equal to x minus 5. So it is a polynomial. Polynomial is a continuous function, and therefore the theorem is proved. One line, you can say, or else you can find the limiting value. And then also there also in limiting value also you after all will make the same result, make use of the same result. That after all you will put at, suppose you have to check its continuity at 7, that at place of x you will put 7, and again you are applying the same thing. See, if you are even writing, like suppose you have to check its in your book there you have been asked to check its continuity for at what point examine the following functions for continuity at everywhere. So see, this will be continuous everywhere except x is equal to minus 5, for which the function is not even defined. So answer would be that it is continuous everywhere. It is continuous everywhere in its domain. Please remember it. You need not to write separately x is equal to minus 5, because x is equal to minus 5 is not even present in its domain. Okay, fourth question. Yes, it's a good one. Please see it. Prove that the function fx is equal to x to the power n is continuous. Fx is equal to, this is x, is continuous at x to the power n, where n is any positive integer. It is if any positive integer plus z. N is the element of z. Okay. Please see this function x to the power n, what it is? A polynomial. A polynomial of degree n. So since fx, please in exam fx is a polynomial. If in exam it comes, you write like this: fx is polynomial. Therefore, it is continuous. Therefore, it is continuous. It is continuous. Write like this. And then, so what you have to find? You have to find its continuity at x is equal to n. You have to check its continuity where? Find its continuity at x is equal to n. Therefore, fn. So it now. Since fx is a polynomial, therefore it is continuous everywhere in its domain. Everywhere in its domain. Now, point n lies in its domain. Therefore, what will happen? Limiting value x tends to n, x to the power n. Will be what? It will be n raised to power n. N raised to power n. Limit x tending to this much. And what is the functional value here? Functional value of at x raised to power n at n, x is equal to n will be what? It will be again n raised to power n. So what you are finding? Limiting value is equal to functional value. Therefore, the function is continuous at x is equal to n. That is the answer. So answer is function is continuous at x is equal to n. Okay. Any doubt, please do ask. Any doubt you can ask me. Okay. Then please see next question. Fifth question. Is the function defined by fx is equal to x if x is less than equal to 1 and is equal to 5 if x is greater than 1. So you have to find is the continuous at x is 0. You have to check its continuity at where is at x is equal to 0. At x is equal to 0. Okay. So first let us define what is f0. f0. f0 will be how much? f0 will be how much? 0 because x less than 1. So functional value at 0 is 0. 1. Now limiting value at when x tending to 0 plus, please see 0 plus. At 0 plus fx. What it will be? Fx will be defined what? When it is less than 1, so it is x. Fx is equal to, so it will be limit x tending to 0 plus. Okay, so what it is? It is nothing, since it is a polynomial, so it will be 0. And then limit x tending to 0 minus fx. What it would be? It would be 5. 5. Limit x tend, because on the left side of 0, no, only at 0 you have to find the limit. Okay, at 0 you have to find the limit, no issues, because x less than 1. It is not 5, it is again x. It is again x. So what it will be? It will be again 0. So it is continuous. Now see what it is happening. Functional value, left hand limit, right hand limit, everything equal. So it is continuous at x is equal to 0. Now you have to find at x is equal to 1. At x is equal to 1. Let us see what it is. Find again, see same thing you have to do. And this will be interesting one. First you find the functional value of 1. X less than equal to 1. So it is how much? 1. So functional value is 1. This is 1. Now limiting value, first you calculate limit x tending to 1 plus. 1 plus how the limit fx. This thing will be equal to limit x tending to 1 plus, and what else? Yes, x is less than equal to 1. So 1 plus is on the right side. So right side it is greater than 1. Please see 1 plus. Where it is greater than 1, what is this thing? It is 5. It is 5. 5 is a constant function. So its value will be 5 only. And the limit x tending to 1 minus fx. What it would be? It would be limit, yes, x tending to 1 minus. And what is the function? How the function is defined? It is defined as x. It is defined as x. Then x is less than equal to 1. So it will be how much? 1. So see, since left hand limit is not equal to right hand limit, therefore this implies function is not continuous. Function is not continuous at x is equal to 1. Because we have already told you, if the function is continuous, then both left hand limit, right hand limit, they should exist and they should be equal. And they should, moreover, they should be equal to the functional value. They should be equal to the functional value. So all these things you have to take into account. Okay. So it is not continuous at x is equal to 1, whereas it is continuous at x is equal to 1. Okay. Then please see question number 6 to 12. They are of the same nature. They are of the same nature, and I will tell you how you would be doing them. I will take question number 7. Question number 7. What it says, your function has been defined like this. Fx is equal to mod x plus 3 if x is, if x is less than equal to minus 3 is equal to minus 2x if x lies between minus 3 and plus 3, and this is equal to 6x plus 2 if x is greater than equal to 3. If x is 6x plus 2 if x is greater than equal to 3. Okay. So now see what we need to do is, and you have to find find all points of discontinuity of f where f is defined by like this. So okay. So first of all, for all the points greater than equal to 3, since what you will write, see case 1, x is greater than equal to 3. So x is greater than 3. So find this is, now here function is a polynomial, 6x plus 2, therefore it is continuous. It is continuous because every polynomial is continuous. Okay, now case 2, when x is equal to 3. Okay, then limit first functional value f3. F3 is how? X is greater than equal to 3, it is 6x plus 2. So it will be 6 into, at place of x how much you are going to put? 3 plus 2. So 18 plus 2, it is 20. This is the functional value. Now, yes, let us find the, see at this point where on one side the function is defined in one manner, on the other side it is defined in other manner. There we have to be cautious. Now limit x tending to 3 plus, right hand limit of this thing we have to calculate. So what it is? Limit x tending to 3 plus you write down. And how the function is defined on the right side of 3? It is defined here. X greater than equal to 3, 6x plus 2. So obviously it will be 6 into 3 plus 2. Okay, 6 into 3, 18 plus 2, 20. And then let us calculate the left hand limit. These are the important points. Left hand limit. On the left side of this thing, the function is defined in what manner? It is defined here. I see. On the left side, it is defined minus 2x. Minus 2x. Okay. It is defined as 2x or minus 2x? Yes, minus 2x. Okay. So 2 into x. X is 3. So it is minus 6. Obviously, left hand limit is not equal to right hand limit. Therefore, the function is discontinuous. So at x is equal to 3, the function is discontinuous. So what this thing is? At x is equal to 3, function is discontinuous. Function is discontinuous. As left hand limit is not equal to right hand limit. Okay. Now case 2 we have done. Case 3. Case 3 will be what? If x is less than 3. Now this is the interval. See, between minus 3 and plus 3, this is the interval. Okay. So here see case 3 will be simple. I am just writing here. Case 3 here when x is lying between minus 3 and plus 3. X is lying between minus 3 and plus 3. Okay. Now here function is what? Here function is minus 2x. This is a polynomial. Okay. So the function will be continuous. Polynomial is continuous as we have done earlier, and you are justified in writing that the function will be continuous. Since it is a polynomial, therefore function will be continuous in this interval. Okay. Case 4 let us do. Case 4 will be interesting, and it will be at minus 3. That is at continuity at x is equal to minus 3, because at x is equal to minus 3, function on the right side is defined by minus 2x. and on the left side it is defined by modulus x plus 3. So we had to calculate the left hand limit and the right hand limit. So we will take this separately here. Okay, case 4 I am taking separately because the points where the function is defined at, so case 4 I am writing here, it is when at continuity at x is equal to minus 3. At x is equal to minus 3. So first of all, let us find the value of function at minus 3. So how function is defined there in here? X is less than equal to minus 3. Function is defined like mod of minus 3 plus 3. So what it is? It is 3 plus 3, that is 6. So functional value is 6. And limit of left hand limit x tends to, yes, minus 3 plus 14. First let us calculate minus 3 plus. So minus 3 plus will come here on this side. So it will be equal of this function. So this will be equal to limit, okay, minus 2x up, and limit x tends to minus 3 plus, and this is your function. This is what? Polynomial. And since polynomial is continuous, and in continuous you can put at place of x whatever the value is given here, because a continuous function is equal to its functional value. So this will be equal to what? Minus 2 into minus 3. So this is again 6. Minus 2 into minus 3 is 6. Okay, let us so calculate what? The left hand limit also. X tends to minus 3 minus. On the left side, how the function is defined? Please see like this. It is modulus x plus 3. Modulus x, so it is limit, yes, x tends to minus 3 minus modulus x plus 3. So this thing we can write to be what? Modulus of minus 3 plus 3. This is again 3 plus 3, that is 6. So left hand limit is equal to right hand limit. Here what you will write? Here left hand limit is equal to right hand limit is equal to functional value. Is equal to functional value. Okay, and each of them are equal to 6. Therefore function is continuous at x is equal to minus 3. So case 4 done. And what will be the last case? Last case would be, that is the case 5. It will be when x is less than minus 3. When x is less than minus 3, what is the function? How it is defined? Yes, function is defined therein as mod x plus 3. Mod x plus 3. Please see, x is less than equal to minus 3. So when f(x) is equal to mod x plus 3 and x is negative, so what you will do? For this is x less than minus 3. So minus 3 here will become what? You can well write it to be minus x plus 3. So since this, what is this? For all values less than minus 3, your function mod x plus 3 can well be written to be minus x plus 3. Since this is what? A polynomial, rather a linear polynomial, and every polynomial is continuous, therefore function is continuous. Function is continuous for every value x less than minus 3. So your function is basically continuous everywhere, barring the point x is equal to how much? I think it was the third case at minus 3, where the left hand limit and right hand limits were different. So this is how you will be doing this question. Now let us move to the next one. Yes. So from question, as I said, question 6 to 7, how much? Question number 6 to 12, they are of the similar nature. Let me take one more question here so that things becomes more clear to you. All this, please make sure that whenever you are trying the question, then you should reason it out also. Now, which question should I take? Okay, let me take question number 12. Question 12 is, yes, what is the function? It is x raised to power 10 minus 1 if x is less than 1, and this is equal to x square if x is greater than 1. Obviously, see, how many cases there could be? Your function, this is your real line, this is 0, 1. On the right side of one function is defined like what? Fx is equal to x square. On the left side of it, it is defined like x. So please see, only one point. Now on right side, the function is continuous. So case 1. See, in exam you will please write like this. Case 1, x is greater than 1. X is greater than 1. So here function is what? Function is your x square. What is this? Since now you will write, since this is polynomial, and every polynomial is continuous, therefore function is continuous for all values greater than 1. Case 2, if x is less than 1, then function is defined what manner? X raised to power 10 minus 1. Please see, if x is less than equal to 1, so when you are strictly less than 1, case 2 is you are strictly less than 1, function is this thing. So this is what? Again a polynomial. Therefore by the same reasoning, you can say that the function is continuous. Case 3 will be an interesting point, where on the left side the function is defined. Hello? हाँ भवि सर बताइए. Anybody? Okay. Now see in here, please अपना microphone please mute कर दें. Case 3 will be an interesting case. Continuity at x is equal to 1. Because here this point is interesting point, because on the left side the function is defined in one way. So first of all, what we will do? Functional value we will find. Functional value at x is equal to 1. So this is symbolically represented as f1. What is the function here? Please see, x less than equal to 1, function is defined like this. So it will be what? 1 raised to power 10 minus 1. Because this is a polynomial is continuous, therefore you can write its value here. Rather you should reason it out. You should write f1 is what? It will be 1 raised to power 10 minus 1. You can write like this. And here you have to write the reason. Since x raised to power 10 minus 1 is polynomial, this implies it is continuous, and this implies whenever a function is continuous, therefore its functional value is equal to its limiting value is equal to its functional value. But here see, you have to simply find the functional value, so you don't need to write also. So 1 raised to power 10 minus 1 is what? 1 minus 1, that is 0. Okay. Now, limit x tending to 1 plus. Let us see how the function is defined. On the right side of 1, function is defined by x square. So it is limit x tending to 1 plus x square. So this is what again? Polynomial. Since polynomial is every polynomial is continuous, so therein functional value will be equal to its limiting value. So limiting value will be equal to what? Functional value. Functional value of x square at 1 plus will be what? 1 square, that is 1. Likewise, limit x tending to 1 minus will be how much? Here function is defined like limit x tending to 1 minus x raised to power 10 minus 1. This again is a polynomial. Polynomial is a continuous function. And in continuous function, what actually happens is that this functional value will be equal to limiting value. So this limiting value, I think you can see it now properly. So this limiting value will be equal to what? Functional value, and functional value will be what? 1 raised to power 10 minus 1. So this is 0 again. So what you are finding here, that functional value is what? Here you have seen functional value at x1 is 0. 1 raised to power 10 minus 1, 0. This is 1. Left hand limit is what? Again 1 here. And from 3, what you are finding, that the limiting value is what? 0. So here see, left hand limit, right hand limits, they are different, therefore this is discontinuous. Therefore function, as soon as left hand limit and right hand limit will be different, so function will not be continuous. You even need not to calculate the functional value. But then see, in these types of questions it is always better to calculate functional value first. So this is how you will be doing the question number 12. Okay. Now please see question number 13 onwards, they are of a different nature. We will do them. Yes. I already told you these are very simple questions. Question 13 is also of the same nature. We will skip it up. Left side it is x plus 5 and on the right side it is x minus 5. So when it is, okay, should I do it? Should I do it, Bhavishat? Okay, let me do it because anything. Fx has been defined to be x plus 5 if x is less than equal to 1 and this is equal to x minus 5 if x greater than 1. This is how your function is defined. Okay, simple. Case 1, x is greater than less than 1. Strictly less than 1. So case 1, fx is how much? One line, x plus 5. X plus 5 is what? Polynomial. X plus 5 is what? Polynomial. So what you will write here, that yes, since polynomial is continuous, therefore function will be continuous. Here you will write every polynomial is continuous. That means every polynomial is continuous. Okay. So for all the values of x less than 1, function is continuous. Case 2, again see, x is greater than 1. Function is defined what way? X minus 5. So similar reasoning, it is again a polynomial. So same reasoning, so continuous. So case 2, so it will be continuous everywhere. Case 3 is important, where, yes, so what is the functional value at 1? X is equal to 1. Case 3 is when x is equal to 1. Okay, because on a real line, see, either it will be less than 1, greater than 1 or 1. So 1, f1. Functional value will be 1. At 1 the function is defined like x plus 5. So it is 1 plus 5, that is 6. Okay. Left hand limit, let us calculate limit x tending to 1 minus fx. So it is limit x tending to 1 minus, and how the function x less than 1. So it is how much? X plus 5. So what it is? It is again 1 plus 5. That is 6. Because this is a x plus 5 is polynomial. And its limiting value will be equal to what? Its functional value. So functional value at 1 will be what? 1 plus 5. So all these things you have to be now perfect. Limit x tending to 1 plus. Now right hand limit here. We will calculate. So it will be limit x tending to 1 plus. And what is the function on the right side? Please see. It is x minus 5. X minus 5. So it is again a polynomial. Since it is a polynomial, students, therefore again see, every polynomial is continuous, and in continuity the limiting value is equal to the functional value. So the functional value of this polynomial at 1 will be how much? It will be 1 minus 5, so it will be minus 4. So again see, left hand limit and right hand limits are not equal. One is 6, other is minus 4. Therefore, the function will not be continuous at x is equal to 1. That will be the answer. This is how you will be doing it. Now, see, question 14 to 17, they are of the same type. Let me take any two of them. 14 to 17, they are of the same nature. Let me do it. Not very different, same thing. Only the number of discontinuous points they have increased. Yes. Question 14 to 16. Okay. Which one you want me to take? Okay, let me take 16 itself. Question 16. And please see, you write all the things with the proper reasoning. Question. Okay, first let me take 14th, then I will take your 16th. Oh, it's a simple one. Okay, fx is equal to how it has been defined, please see. It has been defined like 3. If 0 is less than x is less than 1. Less than 1, okay. Is equal to how much? 4 and 5. 4 and 5. 4 if what? If 1 is less than x is less than 3, and if 3 is less than x is less than 10. Okay. So basically your function is defined from 0 to 10. 0 to 10. Okay. Now see, please see. First let me take case 1. Case 1. If x is less than 1 and greater than or equal to 0. Okay. Case 1 is it now. Here fx is defined what way? Fx is equal to 3. Please see. Fx is what? 3. 3 is a constant function. 3 is constant function. Right now says constant is a continuous. Constant function is continuous. Constant function is continuous throughout real line, throughout real R. Therefore, here fx is continuous. So in case 1, for this thing, the function will be continuous. Okay. Likewise, case 2. Case 2. It is when 1. Now see which case we are skipping. Yes, 1 is less than x is less than 3. Again see, here functional value is defined like 4. So same reasoning, since function is continuous, therefore even for this interval, and likewise for case 3. Case 3. Case 3 is, it is between 3 and x is 10. So function is defined here like 5, and since it is a continuous, so in all the 3 cases the function will be continuous. Now case, what are the points left out? 1, 3 and only 1 and 3, because these are the points where on the left side the function is defined differently, on the right side the function is defined differently. So let us see what are the respective limits therein. So it is always better, case 4 will be continuity at x is equal to 1, and then we will find the continuity at 3, because there also. So continuity at 3, first calculate left and right limit. 1 plus, see how the function is defined here. It will be like limit will be what? Extending to 1 plus, and limit is what? 4, please see. 1, x is greater than 1. So 1 plus it is 4. Function is defined like 4. Constant. So what it is, the limit is 4. Limit x tending to 1 minus fx. So what it would be? It would be limit x tending to, yes, 1 minus. 1 minus function is defined like this. So it will be limit 3. 3 is a constant function, so limit x tending to 3 will be 3 only. So what you are finding, that left hand limit and right hand limits are not equal, therefore function is discontinuous at x is equal to 1. Here see, if you are calculating left hand limit and right hand limit and you are finding that left hand limit is not equal to right hand limit, then no point of calculating the functional value, because for a function to be continuous at a given point, what should happen is that both the limits, left hand limits and right hand limits, they should be equal. We have seen in the theory part, and if they are equal, then you calculate the functional value and show that all three of them are equal, then it will be continuous. If two of them are equal and it is different from the third, then again the function will be discontinuous. So this is case 4. Now case 5, let us see continuity. Only at the points where the function is defined differently. So at x is equal to 3. So again do the same thing. Limit x tending, first you can calculate the right hand limit. On the right side, how the function is defined? This way. It is function is defined what way? X tending right side, it is 5. Obviously see the limits will be different. So it is 5. But here when you are writing 5, then please do write here. The reason, since constant is a continuous function, since constant function is continuous throughout R, is the element of R, therefore you are justified in writing this limiting value as equal to the functional value. And similarly limit x tending to 3 minus fx. Now on the left side of this 3, how the function is defined? It is defined like 4. So it is limit x tending to 3 minus how much? 4. So this will be 4. Same reasoning. Constant function is continuous, and in continuous function limiting value is equal to the functional value. So this is how this same reasoning. Left hand limit not equal to left hand limit is not equal to right hand limit, isn't it? So therefore function is discontinuous, yes, at x is equal to how much? 3. So at 3 and 1 function is discontinuous, and for the rest of the values the function is continuous. So see, these are verbal questions, and only I have already told you that questions will be too simple, provided you can understand the theory part. And even in theory, if you find any difficulty, because we have done it very comprehensively for you people to make sure that you do better questions, difficult ones also. Beyond the book you can go easily. Okay. Now, I think this question 16 is almost on the same lines. So we can skip it up. There only one in the middle, it is 2x, which is a polynomial. So that is also a continuous function. So you need not to do anything else there. 17th question, let us write down. Find the relationship between a and b so that the function defined by, yes, question number 17, please see. It says that fx is defined like this. These types of questions are given in your whole examination also. Ax plus 1. A you don't know, A is some constant. If x is less than equal to 3. And this is equal to bx plus 3 if x is greater than 3. If x is greater than 3, this is how your function is defined. You have to, and further it is given, defined by this thing, and is continuous at 3. Is continuous at x is equal to 3. This is also given. Your function is continuous at x is equal to 3. And it is defined ax plus 1. Yes. If x is less than equal to 3 and is equal to bx plus 3 if x is greater than 3. Okay. So what you need to do? It is continuous. So first of all, let us find the functional value. Where? At 3. Functional value at 3 is what? it will be, yes, a, it is 3a plus 1. Okay, left hand limit x tending to 3 minus fx. Fx on the left side is defined how? It is defined as 3a plus 1. And limit x tending to right side, how it is defined? Function. It is defined at bx plus 3. So bx plus 3 again a polynomial, b is some constant. So it is bx plus 3, so you can write it 3b plus 3. 3b plus 3. That's because bx plus 3 is also a polynomial, and in a polynomial the is a continuous function. So this limiting value will be equal to its functional value. And what is the functional value? 3a plus 1. So this is one question which you will be getting. Okay. So now three things we have got. You have got the functional value at 3, you have got the left hand limit, you have got the right hand limit. Now see, left hand limit should be equal to the right hand limit. So what you should get? Yes, 3a plus, first you write these two equal. 3a plus 1 is equal to 3b plus 3. So what you are getting? 3a minus 3b and is equal to 2. This is equation 1. And how this equation has come? Left, since left hand limit is equal to right hand limit. Since, write down since, therefore you get equation 1. So left hand limit is 3a plus 1, this is 3b plus 3. So you have equated them and you have got equation 1. You know, in order to solve this a and b, for finding the values of a and b, you need two linear equations. So other equation will come from where? You have seen that left hand limit should be equal to right hand limit, and each of them individually should be equal to what? Functional value. Now functional value here, right hand limit is 3b plus 3. So 3b plus 3 should be equal to how much? It should be equal to 3a plus 1 also. So this will fetch you what? This will fetch you what? 3b minus 3a is equal to how much? Yes, it will go other side. 3b minus 3a and this, okay, 3b minus 3a, and then you take this to other side, so minus 2. So what you are getting, this is equation 2. Okay, so fine it is. So what you are getting is multiply by minus, so what you will get is 3a minus 3b is equal to 2. So okay, so you are getting anyway same equation, 1, 2, 3, they are not different, they are, you are getting the same equation. So what you need to do is, okay, so what you need to do, you have to find the relationship between this thing. So what you need to do is, when this type of situation is developing, then what you need to do, any of the value you assign any number, it will have infinite solution as a matter of fact. See, two variables, one linear equation. So it is up to you. If you are assigning b value, suppose 1, so what do you get? 3a minus 3 is equal to 2. So 3a is equal to 5. So a will be equal to 5 by 3. So one solution is 1, a is 5 by 3 and b is 1. Similarly, you can assign any value. One of the variables you can assign any value. So it will have infinite solution. B you are suppose assigning value 2. So what you will get? 3a minus 3 to 2, 6. 6 and 6 you take this side. 8. So a will be equal to how much? 8 by 3. So this way you can find infinite solution for this thing. That's the answer. It's a good question. This was your question number 17. So you, okay, it only says, okay, so that the function remains. Find the relationship between a and b. Okay, even they are not asking the solutions. They are simply asking the relationship. So this is the answer. This is the answer. So done. Okay. But if answers are being sought, then there will be infinite solutions to it, and that these solutions can be obtained in this particular manner. That is, you can assign one of the values, any value, and then other value you can determine. Okay. This is 17 question. Okay. Now let's see. Go further. Yes. Question 18. Find the relation. 18. for what value of lambda the function defined by yes fx 18, question number 18. Yes, fx is how much? It is lambda times x square minus 2x. If x is less than or equal to 0 and this is equal to 4x plus 1, yes, if x is greater than 0. Okay. Now, what is, you have to find the value of lambda, and given it is continuous at x is equal to 0. Continuous, moreover continuous at x is equal to 0. And what else? What about continuity at x is equal to 1? You have also to tell whether the function is continuous at x is equal to 1 or not. So first let me see if x is greater than 0. Continuity, firstly I will take the part. Continuity at x is equal to 1. So when x is greater than 0, how the function is defined as 4x plus 1. Continuity at x is equal to 1. So at x is equal to 1, function is defined what way? This way. 4x plus 1. This is what? Polynomial. This is what? Polynomial. So at x is equal to function fx is equal to 4x plus 1, and this is x greater than 0, isn't it? So f1, since this is a polynomial, therefore obviously polynomial is a continuous function, and therefore it will be continuous at 1. So it is one liner which has been attached to it. Now let us see, we have to determine the value of lambda. And here what we are finding is that, see, the function is defined on the left side by lambda this thing and on the right side by this thing. So what we need to do is, first we find the limit x tending to 0 plus fx. So what it is f, yes, it is limit x tending to 0 plus, it is how 4x plus 1, it is 4x plus 1. So at 0, what it will be, since 4x plus 1 is polynomial, it will be continuous, therefore limiting value will be equal to the functional value. This limiting value will be equal to the functional value of 4x plus 1. So it will be 4 into 0 plus 1, so it will be 1. Then again see limit x tending to 0 minus fx. So on the left side of 0, the function is defined what manner? Lambda times x square minus 2x. So you have to find the limit of this thing, limit x tending to 0 minus. Now this is equal to what? This is the product of a polynomial with a scalar. And you have already done a theorem that k fx, limit of k fx is equal to k times limit of fx. Okay, so you can write lambda times, this is limit x tending to 0 minus x, how much? X square minus 2x. Okay, x square minus 2x. Okay, if x is less than equal to 0. Okay, so what you are finding? Limit of this thing, x square minus 2x it is. Okay. Yes. So what you need to do, okay, x tends to 0. So it is lambda, so that way you won't get the value of this thing. It will be 0. You can put it. 0 minus 0, that is 0. So 0 into lambda is 0. Okay. So what you are finding? Okay. So clearly left hand limit is not equal to right hand limit. Please see, it's a good question. Here you see the question doesn't ask you the value of lambda. For what value of lambda the function defined? Okay. For what value of lambda the function defined by itna is continuous at x is equal to 0. Okay. For what value of lambda the function defined? Okay. So what value of lambda here? Okay, let me check it. For what value lambda the function defined by it like this is continuous. Okay, is continuous. Okay, you have to that will be 0 throughout. Okay, let me see. It is lambda x square, x let me take also common. So x minus 2 if I take common into this, I think can write, yes, okay, like write this thing. So its limit when you are taking 0 minus, okay, so that has to be 0. So this is x greater than 0. You see, you can't do it.
So since lambda vanishes, so for no value of lambda.
So see, this is one good case. If you are correct, absolutely. Hardly there will any there can't be any value of lambda which will satisfy this thing to be equal to 1 for the obvious reason. Because see, this lambda you give a lambda any value. Lambda multiplied by something will never be equal to 1 because you want 1 as a right hand limit. So that's the correct answer. Here you have to be prudent enough. Here see, no such value of lambda exists. Here the answer would be no such value of lambda exists for which this can be continuous, for which function is continuous, It is a good question at x is equal to 0. So please see, for the simple reason that here see lambda is taken outside and this thing will always be 0. And 0 multiplied by anything will always give you 0, whereas you want 1. Please see, right, left, this right hand limit is 1. And here see, unfortunately, lambda, what is the limiting value? Lambda into 0. So what you will write here is, as an explanation would be, that see, the right hand limit, you write just like this thing. Now you write since lambda into 0 can never be equal to 1, therefore no such value of lambda exists for which the function can be continuous. So function has to be discontinuous at x. This is a good question. That's a good question, of course, yes. So that's the answer. No such value of lambda will exist for which the function will be continuous at x is equal to 0. Okay. Now, after question 18, we will take question 19th. Show that the function defined by gx is equal to x minus gx is equal to x minus integral value of x. Okay, is discontinuous at all integral points where this is the greatest integer function less than or equal to x. Okay, this is greatest integer function, everybody knows. So how you are defined? So please see, first of all we will see that how the function is defined. Now let x is equal to x be the element between say k and k plus 1. It will be like this only. X is the element of k in this open interval, where k is any integer. So what will happen, students? Please see, when you have these types of questions, greater integer less than or equal to 1. Okay. Okay, fine. So if it belongs to this interval, then this function gx, how you can write, please see. If it is lying here, please see. Then see, what is this thing, what will be the value of x? It will be k plus 1. And what about this this thing? It will be k. So this is what 1. If x belongs to this interval where k is any integer, then see your function can be written what way? X will be what? K plus 1. X will be what? No, just hold on. Yes. No, x will be, it is lying in this interval. Okay. No. X won't be k plus 1. Just a minute. Gx will be, okay, it will be x minus how much? And less than equal to k plus 1. It will be, and this thing will be k plus 1. This will be and x will be less than this k plus 1. Okay, so gx you can define like this. And what it is? Yes, it is what? This is nothing but x minus, and this is what? K plus 1 is a constant. K plus 1 is what? Constant. You can write it x minus k dash. So what it is? It is a polynomial. It is a polynomial. And every polynomial is what? Continuous. Every polynomial is what? Continuous. Now write down, since every polynomial is continuous, therefore this function will be continuous for every such interval. For every open interval like this thing. Now let us see what happens. Now here, this is case 1. This is case 1. So here, big polynomial, it is continuous. This implies it is continuous. It is continuous. Because every polynomial is continuous, that you have already proved. Case 2, yes. Case 2, yes, if x is equal to k. If x is equal to k. Okay, then what will happen? This function, your function will be defined what manner? Then gx will be equal to how much? Please see, it will be x will remain x, okay, minus, and this will be what? X. If it is k, then it will be x minus k. That's all. Gx will be equal to what? X minus k. When it is like this, okay, fine. And when it is yes, gx is like this, okay. And when x is between k and k plus 1, x is the element of k to k plus 1, means when you are to write this thing, then your gx is how much? This you have already seen, it comes out to be what? X minus k plus 1. Okay, now if x is the element of, please see, k minus 1 to k, then gx let us calculate. Then let us calculate gx. Please see, it's a good question. Here, gx, x lies here. So x will be, no doubt, x minus. And here this modulus x will be how much? If it is lying here, it will be k minus 1. Please see, it will be k minus 1. So different for different manner. In different intervals, it will be differently defined. Okay, so this is how the function will be defined. Now please see. Okay, now fk, functional value at k, let us see how it has been defined. So it will be x minus k. It will be x minus k. X minus k is a polynomial, so k minus k, so it will be 0. It will be always 0. And please see, what is the limiting value at x tending to k plus? Please see, at x tending to k plus. K plus is this interval. So it will be how much? It will be again a polynomial. So it will be how much? Yes, please see, k minus k plus 1. So k minus k plus 1, k minus k minus 1. So this is minus 1. Now please see, you can easily show from here itself that function value is not equal to the left hand limit, right hand limit. Therefore, it cannot be continuous at k. And moreover, if you will calculate the left hand limit also, you will find it differently. At k minus, what the thing is, it is your function is defined this way. This is again a polynomial. So what it is k minus 1, and this is plus 1. So all three different. And that is why I was saying that, see, you need not to calculate even the third. Even the examination, don't waste time. Calculate first two. If the functional value is not equal to the left hand limit, you can easily say that this thing. So what we have shown, and that for each integral value, the function is this function defined this way, which is a combination of a greatest integer function and your identity function. That will never be a continuous function, but for rest of the points, it will always be a continuous function. It is a good question again. Question 90, okay. Yes. Next question, please see. It is question number, yes, 20. Fx is equal to, these are easy one. Fx is equal to, yes, it is x squared minus sin x plus 5. It's continuous at you have to show it is continuous with x is equal to pi. Very simple. What you need to do, see, one way easily is you can easily see it is a sum of three expressions. And this is continuous, x square is continuous being polynomial, sin x you have seen it is continuous everywhere in its domain. This is a constant function. This is again a continuous function. And sum of if there are three continuous functions, then there was a theorem that their sum is also continuous. Sum or minus, isn't it? So that theorem you know it. So making use of that theorem you can see how limit x tending to pi, suppose you have to calculate. So what you will write? It is limit x tending to pi x square minus sin x plus 5. Okay, and this is what? Limit of the sum of three functions is equal to sum of their individual limits. Limit x tending. See, don't get it confused with minus this thing. This thing you can always write plus and minus sin x if need be. If you so whenever in an expression you have certain functions, then whether it is plus or minus, rule will okay, because sum of two is what? You can write limit this thing is x square plus limit of rest of the function, limit x tending to pi of what? Minus sin x plus. In fact, and then again invoking this theorem, what you will get? Limit x tending to pi x square plus limit x tending to pi minus sin x and plus, because limit of the sum of two functions x is equal to 5. And now quite simple. This is polynomial. So what you will get? Pi square. If somebody asks you, please do tell the limit as well. So what it is? It is minus sin pi. And what it is? 5. Constant function. Its limit is what? You have already seen 5. So though the question is not asked therein, but have they asked to calculate the limit? No. If the function defined is not continuous, they only was that it is a continuous. So what you will write? It is continuous because the sum of three functions, continuous function is also continuous. But if they ask you to find the limit, then this will be there. So it will be pi square plus 0 plus 5. So pi square 5 is the answer. So this part has not been asked, but if somebody asks you, you can do it like this. Okay? Okay, next question. So this is just to make you aware that how you will actually write in the examination. And that's the reason that everything has been given to you now. Okay, so now 21 question, simple question, nothing to be done. It is sin s plus cos x, both of them are continuous function. So part A, sin s plus cos x will be continuous, isn't it? And likewise sin s minus cos s will be continuous, and the product of two continuous function is again continuous, so C part will also be continuous. So now 22nd question, discuss the continuity of cosine, cosec, secant and cot functions. Okay, so you know I will take one of them. Let me take this thing of cot and this thing sec. Okay, one different or whatever you want me to take. Cosine, you know the graphs. Cosine function, you know its graph very well. How it is in cosine function is defined everywhere. You know very well. And you have to simply recall it is plus 1, it is minus 1, it is 0, it is pi by 2, it is minus pi by 2, it is plus pi by 2, it is pi, it is minus pi, and this thing cosine, cosec. Cosec is what? Inverse of sine. So its principal branch will lie there in between minus pi by 2 to plus pi by 2. So it is like this, 0 to pi by 2 and then like this, and then reverse here. So what you are finding that at x is equal to k pi, at x is equal to k pi, it is discontinuous. 0, here pi, because here see if you look in the graph, so what you will find, it will be like this. So at pi, so at x is equal to k pi, the function is discontinuous, and for rest of the points it is continuous. Okay, now So this way you will do it. All the graphs have been already told you. And where it is on one side it is going towards plus infinity, other it is going to minus infinity, then of course those will be the point of discontinuity, rest all will be the points of continuity. Okay, 23rd question, a good one. See, this 24th question is again a very good question, and I would like to do it because 23rd, first let us see, they are of the same nature. Fx, this is simple one, it is sin x upon x if x is less than 0. If x is less than 0, and this is equal to x plus 1 if x is greater than 0. Now please see. If x is less than 0, first see case 1. You will always build up 3 cases. Case 1, where x is less than 0. Then what happens? Fx, your function is defined what way? Sin x upon x. Now here see, x is less than 0, so x will not be 0. Function is defined. Both numerator and denominator, what they are? Continuous function. This is polynomial, continuous. This is what? Sin x is a continuous function. And you have seen by this thing, limit of the quotient of two functions is again equal to their individual limits. So if this is continuous, then the division of two continuous function is again a continuous function. That theorem you can invoke, and therefore for x less than 1, this function will be continuous. So right now, since if you quote the theorem, if fx and gx are continuous functions, then fx by gx is also continuous. Fx by gx is continuous. So sin x and x both are continuous. Therefore, by virtue of this theorem, this thing, function sin x by x will be continuous throughout x less than 0. Case 2 likewise is simple. Case 2 is when x is greater than 0. So function here is defined what way? It is a polynomial. X plus 1, what it is? Polynomial. So it will be continuous hoga. And case 3 will be interesting one. So that we are dealing now. Rest 2 cases are simple. Okay, case 3 let us take. Case 3, simple as limit x tending to 0. First of all, how it is defined? It is x less than 0. It should be less than equal to 0, I think. It is x greater than 0. X, okay, case 3, x tending to 0 plus, okay. 0 plus, so what the function is 0 plus, it is x plus 1. This is polynomial, so it is 0 plus 1, so it is 1. Let us calculate the limit at x tending to 0 minus. So 0 minus is what? It is sin x upon x. Okay, at limit x tends to 0, so this is 1, this is the value of limit sin theta upon theta matters in the radius, it is always 1. So 1, so it goes there. Now see, if they are equal, then we have to find the value also. Functional value at 0. So what it is x is greater than 0 or equal to 0, then it is x plus 1. So 0 plus 1, f 0 plus 1, so again it is 1. So here see, its answer is that yes, it is continuous because all three things are equal. Now a very good, 24th is again a very good question, and there in C you have to be a bit careful. 24th question, let me do it because that's a good one. It was just like as you did earlier, that lambda question where no such value of lambda exists. Okay. Now 24th question. Fx is equal to how much, students? It is x square sin 1 by x. And if x is not equal to 0 and this is equal to 0 if x is 0. This is how your function is defined. Okay, very good. Now, please see. Again, see, you will be building up the 3 cases. if a function is less than greater than 0 or equal to 0, then it is defined like this thing, x square into sine 1 by x. X square sine by 1 by x, it is now the product of two functions. One is sine and this thing. This is polynomial, this is continuous function, this is the product of two functions. Right now. See, please write down first of all, fx, because you should know it, fx is product of two continuous functions, namely that is x square and sine 1 by x. Therefore, this implies their product. Therefore, their product will also be continuous. Their product will also be continuous. So this part of the thing simple. Only for the left hand and right hand, only a 0, where function is defined differently. There we had to check it. And this is a good question. Please see. Functional value at 0 is what? It is 0. X is equal to 0. So one thing is okay. Functional value at 0. You have calculated. Now left hand limit, let us calculate. Left hand limit, if x is 0, then left hand limit x tending to 0 plus or minus. Both ways it will be same. X square into sine 1 by x. Okay. How much it would be? Please see. Well, it would be, yes, limit x tending to 0, so x square 0 plus and limit x tending to 0 plus sine 1 by x. Now here see, this is a very good question. Please see. Limit of sine, I am writing here because maybe limit sine 1 by x. Please see, this is a very good question. X tending to 0. Whether left or right, same thing. Here I will calculate only the limit straight away, because limit of two functions is equal to, I will not even write plus minus. I will write like this. And limit of this polynomial is 0, okay? So finite, and then the limit of sine 1 by x, that we have to see. This limit doesn't exist. This limit does not exist. For the simple reason, what actually happens when x goes to 0, please see. When x goes to 0, 1 by x will go to infinity. And your function will keep on fluctuating between plus 1 and minus 1. See, this limit will not exist. This limit will not exist. Here, see, what the good thing is that this limit is not existing. So this limit will not exist. But see what the thing will be. So that way we won't be able to calculate it. But see, this limit is 0. This limit is 0. So 0 into this thing will make the whole thing 0, because see, whatever value it takes. So we can, if we write like this, we won't be able to do it. But if we write like this, because this will have a finite value. This will have a finite value lying between plus 1 and minus 1. And this thing can be made smaller. Please see, there is no other. This whole function can be, because here x can be given very small value, point say 1001, into you take the greatest value plus 1. So it will be what? Very small number. So what you are showing, that yes, it is converging towards a small number, 0. It is converging towards 0, and therefore this limit is 0. This limit is 0. But if you write like this limit will not exist. Sine 1 by x, it will keep on fluctuating between plus 1 and minus 1. So always remember, sine 1 by x, x tending to 0, this limit will never exist. Whether it is left hand limit or right hand limit, it will never exist. Okay. So, but then what actually happens? You keep it like this, interpret like this, sine 1 by x, it will vacillate, it will fluctuate between plus 1 and minus 1. Okay, fine. But then this x square is making 0. X square is making very small. You give a small value because the maximum value it can acquire is plus 1 or minus. The minimum value is minus 1. Rest all the value will be lying between plus 1 and minus 1. So it will become more this thing. This x square will make it 0. So whole thing becomes 0. That is why this is the good interpretation. Otherwise, please remember limit x tends to 0, sin 1 by x will not exist. I stop it here with the request that you will do the remaining question. They are as simple as these ones, and if any difficulty, please I will do it the question first, then I will take the differentiability. Okay, thank you.